As a Vedantu Karnataka, this is Catherine, your physics master teacher. So quickly, can you let me know if I'm audible and visible? Let me also check. Yes, I'm audible and visible. Right? Hi Sinchana, hi Vinay, hi Movies World. Yes, start I too. Okay? So, yes. Are you all ready for your exam 3? You have your first exam is physics, right? Prepared? Yes, Chandrika is also asking the same question. Did you guys all prepare theory? You're all giving motivation to each other. Silent Hearts giving motivation to everybody, saying you'll all pass, don't worry. Students, all the best for your exam, okay? And you don't have to be tensed. You can all do it, okay? So I will be doing 3 lectures before the exam, today, tomorrow, and day after tomorrow. So I'll tell you all expected questions, numericals, most important questions, everything you need for your exam. So follow these videos and don't worry, okay? You will all crack exam 3. Okay, stay confident. I know it's difficult, a third exam. It's very difficult. We understand that. Okay. So stay focused. Don't waste time. You have few more days. So let's start today's class. Roshan, you're fully dependent on me. Okay, Roshan, you can depend on me. Don't worry. Okay. All of you stay strong. Work hard. Don't waste the next 3 days. Okay. Next year, if you're looking for offline classes for Vedantu, we have our offline center in Bangalore, which is in JP Nagar. Okay. Okay. So let's move on. Let's do most expected questions. We will do chapter wise. Yes, I'm going to give you, expected questions today. I also have 2 more lectures. Okay. So all these 3 lectures will be more than enough for you to definitely pass and score good marks. Okay. Ma'am, I recorded to shout out. Okay, the next class I'm going to do 2 markers, 3 markers, and 5 markers. So if you do all that, you should get above 50. Okay? Movies ka world. You do whatever is there in this lecture. Okay? Okay. So let's start. Yes? Are you all ready? If you're all ready, can you all put some fire emojis in the chat? So I also get some energy to start. Quickly, put some fire emojis in the chat. So we'll start from the first chapter, which is electric fields and charges. Okay? Okay. So first question. It's a very famous question. Give 3 basic properties of electric charge. Okay. What are the 3 basic properties of electric charge? Number 1. Charge is additive. What does additive mean? If there are 4 or 5 charges, the total charge is what? You just add them. So if there are 4 charges and you want to find out the total sum, Q1 plus Q2 plus Q3 plus Q4. Charge is additive. Okay. Second point, charge is conserved. What does that mean? That you cannot create a charge nor destroy it. Charge always flows. So whatever charge comes in will be the same as the amount of charge going out. You cannot create it or destroy it. It's always conserved. Next, charge is quantized. What does that mean? See, for example, let's say you have 5 mangoes. No, not mangoes. What do I say? Okay, let's talk about charge itself. Okay, let's say you have 5 charges. Okay, and each charge is 1.6 into 10 raised to minus 19. The second charge will be what? 2 times 1.6 into 10 raised to minus 19. The third charge will be 3 times 1.6 into 10 raised to minus 20. You can't have a fourth charge which is not a multiple of 1.6 into 10 raised to minus 19. It will always be a multiple of the initial first charge. That is what quantized means. So if the charge of one charge is Q, then seven charges will be 7Q. Whatever value of Q has. And the 10th charge will be 10Q. Okay? That is what it means. I will inform, okay? Yeah. Yes, very good, Vanity. So Q is equal to NE. Yes. So Q is equal to NE means E is the charge. So whatever the total charge, let's say there are 10 charges. 10 charges will be 10 times the charge of 1. Okay? Yes. So that is charges quantized. Next. Yeah, movies ka wall, it's not uploaded. I will upload it. I know I'm telling this in all classes. There's a small problem. I'll upload it soon. Okay? Yeah. State and explain Coulomb's law in electrostatics. Next question. What does Coulomb's law state? That you have two charges. Okay? You have two charges. The first charge is Q1. The second charge is Q2. Now, these two charges will have a force between them because they are both charges. Yeah, they're both charges. Okay, so they have a force between them. So this force is directly proportional to the magnitude of the charges, which means it's directly proportional to Q1 into Q2. Okay, so the force F is directly proportional to Q1 into Q2. Now it is also inversely proportional to the square of the distance between them, which means F is inversely proportional to R square. So what is the scenario here? Q1 charge, Q2 charge, they are separated at a distance R. Okay. So this is Q1, Q2, this distance is R. So Q1 and Q2 will experience a force which is directly proportional to Q1 into Q2 and inversely proportional to the distance R square. Now to remove the proportionality, you put a constant which is 1 by 4 pi epsilon naught. Okay. This is Coulomb's law in electrostatics. Yes, just like Silent Heart said, I will upload it. Okay. I'm really sorry, students. I'm really, really sorry. Today I will upload it. Okay. Yes. Yes. Okay. So is Coulomb's law clear to all of you? These are all, commonly asked questions. Next, properties of electric field lines. Next question is the properties of electric field lines. So first thing, the electric field lines you can see in this picture. Let me see if you can see. Yeah, I think you can see. So first thing, you can see that they do not form closed loops. See, here it goes out, but it's not making a loop like this. Okay, that's the first point. They do not form closed loops. Now, you can see each of these field lines are individual, isn't it? There is no field line like this or a field line like this. There is no field line like this nor like this. It's not going to intersect. Each field line is passing alone. It's all close to each other, but none of them cross each other. That's the second point. They do not intersect each other. Now, they do not pass through a conductor. Okay. So if you have a positive charge, if you have a conductor, field lines are always on the conductor. They do not pass inside the conductor. Next one. They are normal to the surface of a charged conductor. So if you have a conductor, it's always normal or perpendicular to the surface. Electric field lines start from positive and end on negative charge. That you can see in this picture. If you have a positive charge, field lines always move out. If you have a negative charge, field lines always move in. Okay? Okay? Yes? Clear? So that's the different properties of field lines. Field lines always start from positive charge. If you have a positive charge, field lines always move out. If you have a negative charge, field lines always move in. Okay. Next. Let's move on. Okay, this question is okay. So, electric field lines in case of positive charge and negative charge. So the question is draw field lines for a positive charge and negative charge. Same thing as I said, if you have a positive charge, first you put a positive charge and you draw all the field lines moving out. Okay? What all things should you keep in mind? The field lines shouldn't cross each other. They shouldn't touch each other. They should be individual lines all moving out. Now, if it is a negative charge, all the field lines should move in. Okay? Yeah? Chandrika, don't worry. You will pass. Okay? We're all giving you confidence. All of you will definitely pass. But follow the videos properly. Okay? And make sure you practice derivations. You will definitely get questions from what I'm doing in the next 3 classes. Okay? So, I have done a video on MCQs, 100 plus MCQs. So, for exam 2, so many students came and told me that they got 15 on 15 just referring that video. Okay, so you can all go check out that video also, 100 plus MCQs, Vedantu Karnataka channel. Okay? Not the whole physics syllabus, the most important part of the syllabus. For all chapters I will be teaching today. Okay, next question. Electric field lines in case of a pair of equal and opposite charge. So first thing that you need to know is if you have two equal and opposite charges. For example, you have a positive charge and a negative charge. Let's say both of them have the value 5 coulombs each. Okay, they have the same value. Then it is called as a dipole. Okay, so what's a dipole? Equal and opposite charges. It's called a dipole. Okay, so first you have a positive charge, you have a negative charge. We already learned electric field lines start from the positive charge, they go into the negative charge. That is what is happening here. They start from the positive charge, they go in to the negative charge. They go out from positive, they go in to the negative. Okay? Alright? So that's how the electric field lines will look if you have a dipole. Now, if the question is draw the electric field lines for a pair of dipole or for a dipole, then what you should know? You should know dipole has positive charge and negative charge. You should put them, draw field lines positive to negative. Okay? Now, if they ask you to draw electric field lines for a pair of equal and similar charges, which means a positive and positive or a negative and negative. So if it's positive and positive, you can see field lines always move out. So for both field lines move out, so it will actually be something like this. You can say field lines move out in both. Okay. Okay. Silent Heart, what's your actual name, dear? Now you're giving too much, a lot of support. Now, if it's a question is negative charge and negative charge, how will the field lines be? The field lines have to move in. They have to move in. Okay? Yes. Hi Pallavi, I'm good. How are you? So that's how field lines will be for the different sets of charge. Next question. Movies ka wall, you can start from this video. Okay. So I already did 3 marks and 5 marks, but I will be doing one more video of 3 marks, 5 marks and 2 marks together. So you can watch that. Okay, you can watch this. I have 3 more classes. In the third class, I'll discuss numericals also. So you can watch all 3 classes. You will definitely pass. You will actually score more. You will not just pass, you'll score more. Hi, Rohan. Okay. So the total electric flux through any closed surface. Okay, yeah, Gauss law in electrostatics. Okay, so what is according to Gauss law? You have a closed surface. Okay, let's say you have a. Can you see, students? Yeah. Let's say you have a closed surface. Okay, and electric field lines pass through the surface. Okay, you have a closed surface. Electric field lines pass through the surface. So the total electric field lines that are passing through this closed surface is equal to 1 by epsilon naught times the total charge enclosed by that surface, which means the total charge on that surface. Okay? Okay. Yeah. So you have a surface. The total electric flux through closed surface is equal to 1 by epsilon naught times the net charge. So total electric flux is given by what? Phi. So phi is equal to Q is the total charge divided by epsilon naught. This is also very important. Gauss law in electrostatics. Okay, movie covered. I will consider that. Okay, I'll try to do the class early. Don't worry. Enjoy with Bhairava. I don't know if I'll be doing MCQs because I've already done a class on 100 plus MCQs. You'll have to refer that video as well if you want to get 15 out of 15 for MCQs. Okay, that worked for exam 2. For exam 2, many students got 15 out of 15 watching that. So you can watch that as well if you want to score well in MCQs. Okay, next question. Expression for torque on a dipole placed in a uniform electric field. Okay, so as I said, what is a dipole? Two charges which are equal and opposite. Now here what I am doing, I am taking these two charges, placing it inside an electric field. Okay, so I am taking the first charge which is this, the second charge which is at B. Okay, one charge is at A, one charge is at B, and they are at a distance of 2A. Okay, so these two charges are at a distance of 2A. Now they are also in the presence of an electric field which is in this direction. Okay, so that is the electric field. Alright, is this much clear? Students, diagrams very important. Okay, so for some derivations, if you don't draw the diagram, they'll cut full marks for derivation. You will get 0 even if you by heart and write all the steps. So please learn diagrams. Okay, they are not that difficult. Okay, you have two dipoles, A and B, and then there is an electric field E. The dipoles are separated at a distance 2A. This is minus Q, this is plus Q. Okay, now there is a force acting on both in opposite direction. So if this is the dipole, one force is up, one force is down. Now what is this theta? Theta is the angle between the dipole and the electric field. Okay, so this is a diagram. Now derivation is very easy. First thing you need to know, what is torque? Torque is like a force. Okay, so these are two charges that is placed in another field. So what happens? There is a force that these two charges will experience because of the field. So that force is equal to magnitude of either forces into perpendicular distance. Now, what is the magnitude of the electric field? E. Magnitude of charge on the dipole is Q. So E into Q. What are the two forces? The electric field and the dipole. So electric field is E, dipole is Q. Now what is BO? BO is the distance. BO is the distance. Okay. Now, from triangle BOA. So, if you look at this, from triangle BOA, okay, from triangle BOA, what do you get? You will get, what is BO? BO will be AB into sine theta. Okay, so and then BO is 2A sine theta, AB is 2A. So here the most important thing is you have to know the formula. Okay, because in numericals also you will get this formula. Torque is equal to PE sine theta. Now how did I get P? P is a new term that you will learn here. P is nothing else but E, sorry, not E. P is nothing else but 2A into Q. So 2AQ is written as P, PE sine theta is torque. So you can also write it as Q cross 2A is P. Same thing, 2 into A. Okay? Yes, you need to remember the equation. That is the most important part here. Okay? Okay. Now, next question. This is not that important. This is just vector form of torque. So, we already learned that torque is PE sine theta. So, depending on the value of sine theta, the torque will be minimum and maximum. So, when will you have minimum torque? When theta is 0. So, when theta is 0, torque will be 0. When theta is 0, what happens? Sine 0, so torque will be 0. Now, if theta is 90, sine 90 is 1, so torque will be PE, which is maximum. So, maybe for 1 mark, if they ask you, what is the condition for minimum torque? You should know it is theta is equal to 0, torque will be 0. Theta is 90, torque will be PE. Okay? Yeah. So, these are all some important topics from the first part. Next is electrostatic potential and capacitance. Now, first question that you can expect here, first concept is what is an equipotential surface? Okay, so what is an equipotential surface? It's a surface which has the same potential everywhere. Okay, so any surface, let's say you have a sphere and the potential or voltage is same at all points, then it is an equipotential surface. Now, for equipotential surface also there are lots of properties. The first property is that no two equipotential surfaces can intersect. Okay, so if you have two equipotential surfaces, they can never intersect. Now, work done is 0 in moving a test charge over an equipotential surface. Why is that? So, imagine you have an equipotential surface and you take a charge and you're trying to move it through the surface. See, all over the surface, the potential is the same. So, when you move this charge, test charge through the surface, wherever it is moved, it is having the same effect. It has the same the same force acting on it. So that is why there is no extra work done there. Okay. Direction of electric field is always normal. So if this is the surface, direction of electric field is normal to it. Equipotential surfaces are closer in the region of stronger electric field. Okay. So stronger electric field surfaces are closer and they are further away in the regions of weak electric field. Okay. Electric field due to dipole derivations, I will discuss it. Okay. So, I am discussing it in 5 markers. Okay. So, don't worry, everything I'll discuss, but you have to follow all the 3 videos. Okay. Alright. Next question. Here I'm just going through the most important concepts and from where you can expect a lot of questions. Okay. Next is the relation between electric field and potential, or something to show that electric field is negative in electric potential gradient. Okay. So what you will do? So what is the condition here? You have a charge plus Q. Okay. Let's say this is point B. This is point A. Now there is an electric field. Now, what I am going to do, the distance between the 2 points B and A, the distance is dx. Now I have to find out the potential difference between A and B. What is potential difference? V. Okay. The potential difference between A and B. So potential difference is basically the work done in bringing a test charge. So potential difference dV will be the work done dW to bring a charge Q naught. Okay. Now potential difference is dW by Q naught. Now what is dW? dW is work done. When can someone say, when what is work done? So I can say work is done when there is a force applied and a distance is moved. For example, if I keep on pushing a wall, there is no work done there. But if I'm, Hulk and I push the wall and the wall moves, that is when there is work done. Okay, so work is done when a force is applied and a distance is moved. So that is why dW is F, force has to be applied, into dx. That means it has to move by a distance. Divided by the charge Q naught, negative sign to show the direction. Now we've already learned in first chapter what is electric field E. E is the force divided by Q naught. Okay. Now what I will do, I will substitute that in dV. So F by Q naught, I will write it as E. So this becomes minus E into dx. So from this minus E will be what? dV by dx. So I will just substitute this here. Okay. Okay. I will smile how many ever times you want. Okay. You all should do exam 3 very well. That's all. Okay. All the Vedantu Karnataka teachers are putting in a lot of effort, students, to teach you everything for exam 3. Okay. See, we get nothing out of it. We're giving you free classes. So the only thing we need is your support. Okay. Yes. Are you happy, movies covered? Okay, so this is a relationship between electric field and potential, and this also shows that electric field is the negative of electric potential gradient. Okay, next important topic in this chapter is polar molecules. So in polar molecules, where is it? Yeah, in polar molecules, the main important thing is they're molecules with centers of positive and negative charge. The centers of the positive and the negative charge, they do not coincide. And each of these molecules have a permanent dipole moment. So these molecules are unsymmetrical. They're not symmetrical. For example, HCl, H and Cl. What is the symmetry here? They are not symmetrical and the centers do not coincide. They do not have permanent dipole moment. Okay. Now non-polar, see, I will give you a small tip. Learn one. Okay. Learn polar. If you learn polar, non-polar is the opposite. So if you learn that polar molecules are molecules in which centers of positive and negative do not coincide, then you should know non-polar is the opposite, which means centers and center of positive and negative should coincide. Then for polar, you learn they have permanent dipole. So non-polar should be no permanent dipole. Polar is unsymmetrical. So non-polar should be symmetrical. So if you learn both, you will get confused. In the exam center, you will sit and think, okay, which one has dipole moment, which one do not coincide, polar, non-polar, all confusion. So learn one thoroughly. Okay. Learn polar molecules or non-polar, whichever is easier for you. You learn that one thoroughly. The other one is going to be the opposite. Learn one example also. One example of polar, one example of non-polar. Okay. Okay. Next question. Expression for capacitance of a parallel plate capacitor without any dielectric between the plates or parallel plate capacitor. What is the expression? So if you have a capacitor with two plates, okay, so the capacitance C is going to be equal to epsilon naught A by D. So A is the area of the plates, and D is the separation. It is the separation between the two plates. Now what I'm going to do is I'm going to take this capacitor, put it in some dielectric medium. Okay, like for example, let's say you put it in water or you put it in some liquid. Then what happens to this equation? There comes another constant, which is epsilon r. So this becomes the new equation. Epsilon r, epsilon naught, A by D. Okay. Next, factors on which capacitance of a parallel plate capacitor depends. It's already from the formula itself, you know. It is directly proportional to area, inversely proportional to D, distance between the plates. It's also, if it is in a medium, it's also directly proportional to the dielectric constant. Okay. Next chapter, current electricity. You have to learn derivations as well, that I will discuss in the next class. Okay, so for all the 5-mark derivations and 3-mark derivations, 2-mark small derivations, all that I'll discuss in the next class. I mean, here also I will be discussing some derivations, but here we'll mainly look at the most important topics. Okay, next is current electricity. In current electricity, the most important thing is Ohm's law. What is Ohm's law? So if you have a wire, okay, and you have some voltage and some current passing through the wire, okay, voltage is always proportional to current. Okay, so the current in any conductor, the current will always be proportional to the potential difference applied across its ends. But one condition is there: the temperature and any other physical conditions, like the atmosphere, whatever it is, everything should be a constant. Okay, so temperature should be a constant. So to remove this proportionality, what I can do is I can add a constant. So I can say V is proportional to I will put an equal to and a constant, and I will say V is equal to IR. Okay, so V is proportional to I, V is equal to IR. Okay. Okay. Next is the limitations of Ohm's law. What are the limitations of Ohm's law? In the law itself, we say that it has to be at constant temperature, which means it is not applicable for metal conductors at very low and very high temperatures, because it is applicable only at a constant temperature. Next is, it is not applicable for semiconductors or diodes. Why? Because Ohm's law is only for conductors. It is not for semiconductors nor for diodes. Next is, Ohm's law fails if current varies non-linearly with voltage. Exactly. What is Ohm's law? Voltage and current are proportional. So it fails if current and voltage are not proportional. It also fails if the relation between voltage and current is not unique. Let's say voltage and current have two random relationships. That means when voltage increases, current might increase, might decrease, might stay constant. So if it's like a random relationship, then Ohm's law will fail. Okay, Ohm's law is only obeyed if voltage and current are directly proportional. Okay, very good. Yes, Silent Heart says, like Madi, subscribe Madi. Okay, all your friends who are preparing for exam 3, please send this video to them. Let them also sit and study with you. Okay, so people who don't know about these channels like Vedantu, Karnataka, they are missing out on all of this content, right? So please be generous. Please send this to your class group. Send this to everybody who is preparing for exam 3. Help them. Let's all help each other and grow. It will be a beautiful world that way, right? Yes. Okay. Next is factors on which resistance of a conductor depend. So what is resistance? If you have, current flowing through, okay, if you have current flowing through a conductor and let's say some of the current is opposed, that opposition of current is called resistance. Now resistance is equal to rho L by A. So resistance depends on what all factors? From this equation itself, you can say it depends on the length of the conductor. It depends on the area of cross section of the conductor. Two other things are nature of the conductor and temperature. Okay, so those two things are mainly because of resistivity. Resistivity depends on the nature of the conductor and the temperature of the conductor. Okay, now both of these together will affect resistance of a conductor. Okay, so from this question you already have the answer for the next question, which is factors on which resistivity of a conductor depend. It depends on the nature and the temperature. Okay. Next is temperature resistivity graph. For different elements, the resistivity and temperature varies in different ways. So you can see in the first one, copper is like this. For semiconductors, it decreases. For alloys are mixtures of metals. For that, it is like this. Okay. Nitya, most important numericals I will do. Okay. Probably in my third class. This is my first class for exam 3. I mean, I've already done classes, but the last minute revision. This is my first class. Tomorrow I have one more class. In day after tomorrow's class, I'll do numericals. Okay. So please tell all your friends to watch these 3 videos and go for their exam. Okay. Help them. Send this to all of them. Next, obtain an expression for drift velocity of electrons in terms of relaxation time. Now, what is drift velocity? What is relaxation time? So, drift velocity is the velocity by which electrons move inside a conductor. Now, when these electrons move inside a conductor, they all hit against each other. It's like you are in a classroom without teacher and you're all running around and you all go hit into each other. You wouldn't do that because you have eyes, but electrons don't have that. So, they will just go and hit into each other. So, when 2 electrons hit and then they move until they hit the next electron, there is a time gap, right? So, the time gap between 2 collisions is called relaxation time. So, they hit an electron and then they start moving. The time until they hit the next electron, that is called as relaxation time. Okay? So, V is equal to U plus AT. From this formula, let's do that. Now, in the absence of an electric field, when there is no electric field, the electrons are not moving. So, initial velocity U is 0. Now, when there is an electric field, the electrons start moving with a velocity which is equal to drift velocity. That is where V is equal to VD. Okay? Yeah. And then time is equal to tau. Okay? So, the time taken, the relaxation time is tau. So, I will get the formula Vd is equal to A into tau, which means velocity is acceleration times time. From where did I get this formula? From this formula. V is equal to U plus AT. So, V is equal to U plus AT. U is 0 because initially without the electric field, electrons are not moving. So, from this, V is equal to A into T. What is V? V is Vd. A is just A and time is tau. Now, from Newton's second law in first PU, you have learned F is equal to ma. So, what is A? A is equal to F by m. Okay. So, A is equal to F by m. So, if A is equal to F by m, what is the force? Force is charge into electric field. What is the charge? Charge of an electron is E. Electric field is capital letter E. Force is minus E by m. Now, I just substitute the value of acceleration for Vd is equal to A tau. So, in Vd is equal to A tau, instead of A, I will write it as minus E by m into tau. That's how I get this equation. Okay? Is this clear? Yes? This is clear. Can you all put some fire emojis in the chat? Let's have some energy in the class. Are you all sleeping? Silent Heart is going. I miss you, Silent Heart. Put some fire in the chat, students. Let's have some energy. Okay, next question. Derive the expression for current in terms of drift velocity. So, one formula for current that we already know. What is current? Current is the flow of charge in a certain amount of time. Okay, so if 10 charges flow in 5 seconds, it's going to be 10 by 5. So current, what is the definition of current? Flow of charge. Okay, so flow of charge in a certain amount of time is current. Now what will the total charge be? The total charge will be the number of charges, which is n, into the area of the conductor, into the length of the conductor, into the value of one charge, which is E. Okay, so Q is going to be equal to N is the number of charges, A is the area of the conductor, L is the length, and E is the value of one charge. Okay, so now I will substitute that in my first equation. I is equal to Q by T. So now what will I be? I will be NAL E by T. Okay, now VD, okay, VD is equal to, here we've not done that. Okay, VD is equal to, basically it is equal to the amount of current by time. Okay, VD is equal to this. So, not the amount of current, length of the conductor by time. Okay, this from your basic formula in your school you have learned. Velocity is distance by time. Same thing. Here velocity is Vd, distance is L, time is T. So this L by T, I will write it as Vd. Let me take a nice color. So this L by T, I will write it as NA Vd E. Okay, so that's how I get the expression, the relationship between current and potential difference. Okay, so I is equal to NAVD E. Okay, next question. Mention the expression for current in terms of drift velocity. Yeah, so here this is just a question which is like, subsidiary to the, here, if this is like a 1 marker or 2 marker, you only need to write down the expression. I is equal to NEAVD. How you got that? You already know the derivation now. Okay, next question. Relation between current density and conductivity of a conductor. Derive the relation. J is equal to sigma E. Okay, I have to derive the relation. J is equal to sigma E. Okay, I'll start with the basic formula from Ohm's law. What is Ohm's law? V is equal to IR. So from Ohm's law, I is V by R. First formula. And we already learned the formula for resistance. Resistance is rho L by A. In this video itself, I've taught you that. Resistance is rho L by A. Now, what I will do, I will substitute the value of resistance in this equation. Okay. So I is equal to V by R. Instead of R, I will write it as rho L by A. Okay. Now this will be what? VA by rho L. Now what I can do? I can take A to the other side. So what happens? I by A is equal to 1 by rho V by L. How did I get that? Simple cross multiplication. I took this A to this side. Okay, that's all. Now what I will do? I will do some substitution. That's how I get this equation. I by A is equal to 1 by rho V by L. Now I by A is what? Current density J. Substituting. V by L is electric field. E. 1 by rho is sigma. So combining all that, you will get the equation. J is equal to sigma E. Okay? Yes? No? Is this clear? Okay. Let's move on to the next question. Expression for conductivity of a material in terms of relaxation time. Okay? So, the question can be in two ways. It can be either asked as derive the expression for conductivity of a material in terms of relaxation time, or it can be asked as derive the expression sigma is equal to Ne square tau by m. Okay? Any one of this question can be asked. Answer is the same. What is the answer? Let's look at the answer. Yes. Are you all already sleeping? Okay. So first, see, every expression is important. Here we are starting with the expression that we derived in the last question. Because we have J is equal to sigma E. From where do we have that? From the previous derivation. So you have to know the final answers. So from this you will get sigma is equal to J by E. Simple math. I know all my smart students can know all this math. So I already know J is equal to I by E. I also know sigma will be equal to 1 by AE. J is equal to also I've taught you, no? Yeah, J is 1 by A is already there. Not 1 by A, I by A. Okay, this is I. In case you get confused, I by AE. Now what is I? This also we learned in one previous derivation. I is equal to NAVD into E. Yes. So what will sigma be? NAVDE divided by AE. Okay. Yeah. NAVDE divided by AE. Now, what is VD? VD is EE by M. Okay. So this is how this equation is clear. A and A will cancel. Okay. One more thing. You might get confused if I put here. This E is charge. Yeah. Now it's clear. So sigma is equal to NVDE because A and A will cancel. Now we've already discussed VD is what? Acceleration. Force by M. Force is EE, so EE by M. So I will substitute that. So this will become NE EE tau divided by EM. So this becomes NE square tau by F. So sigma is equal to NE square tau by M. See, this equation is what I've used. The equations we derived. Okay, so here there is a tau. Okay, yeah. VD is EE tau by M. Yes, everything else is fine. Full important questions we'll do. Okay, don't worry. Okay, let's look at the next question. All the chapters are going to cover in this live question class. Okay, not all questions, but all chapters. Now 5 markers and 3 markers and 2 markers separately I will do tomorrow. Okay? Okay, Devil King. Next question. Two cells of different EMFs and different internal resistances are connected in series. Find the expression for equivalent EMF and equivalent internal resistance of this combination. Now I have A, B. In between A and B, I have a cell. Now in between B and C, I have another cell. Now I have two cells. I want to find out the equivalent EMF and equivalent internal resistance, which means the EMF and internal resistance between A to C. Okay? Between A to C. So my final answer will be the total resistance of E1 and E2 together as one cell E3. Okay? Between 2 points A and C. Okay? Is this clear? Do you understand what you are asked in the question? You have two cells, so I'm going to make that into a combined EMF of one cell. That's all. Okay. Zara, I already said numericals I will do. Numericals I will do on Monday. Okay. In my third lecture. Okay. Is that fine? Yes. MCQs, you can just search on Vedantu Karnataka channel. You can search 100 plus MCQs by Catherine ma'am. So you will get a video on MCQs, which was very useful for exam 2. It has to be useful for exam 3 as well. Okay. So now, potential difference between the points A and C is given by V1 plus V2 because this is connected in series. In series, okay, one thing you need to know, in series, voltage is always shared between components. Okay, so if you have 5 cells, the voltage, total voltage coming will be shared between all 5 cells. So V is V1 plus V2 plus V3 plus whatever it is. How many ever cells are there, it will be there. Now, voltage across one cell is the EMF minus current times the internal resistance. So now we will just substitute that for each. So V is V1 plus V2. So V1 is what? E1 minus IR1 plus E2 minus IR2. So V is equal to IR1 plus E2 minus IR2. Now V is what? E1 plus E2 minus IR1 minus IR2. Now I'll take the common terms outside. So V would be E1 plus E2. I'll take it together. The minus I'll take it outside. I'll take it outside. What remains? R1 plus R2. So from this, I can write V as E1 plus E2. I will just write it as ES. So whatever alphabet you want. ES minus I times RS. So what is ES? E1 plus E2. Now what is RS? R1 plus R2. Okay. Why did I put ES? I just put it because it's in series. Hello, Nishu. Good evening. Okay. Now same derivation you have to do for parallel as well. In parallel, I have two resistors, two cells in parallel. I'm going to find out the equivalent resistance and equivalent EMF if they become 1. Okay. So the first diagram and the second diagram, they're actually the same thing. So here this EP is basically these two together in parallel. It's the same thing. Okay. So as I already said, in a series circuit, voltage is divided. Similarly, in a parallel circuit, voltage is the same, but current is divided. So total current will be current across each individual component. Just like in series, total voltage is voltage across each component. In parallel, current is current across each component. So here, V1 equals V2 equals V3. Voltage is the same, but current I is equal to I1 plus I2 plus I3 plus I4. It just goes on like that. Okay. So current is equal to I1 plus I2 plus I3. Now let's take the general formula. The same formula that we used here. V is equal to E minus IR. Okay. Same formula. V is equal to E minus IR. But there what I did was I have to write it in terms of V. But here I'm going to rearrange it and write it in terms of I. Okay. So what will I write? I will write it as I is equal to V minus E. Okay. IR is equal to V minus E. And then I is equal to V minus E by R. I is equal to V minus E by, sorry. Yeah, I know what you're all asking. Ma'am, isn't it E minus V? Yes, it is E minus V by R. Because it's minus IR, right? So to make it positive IR, it has to be E minus V. Very good. Okay. Now what I will do, I will substitute it in the formula. I is equal to I1 plus I2. So what will I write? E1 minus V is the same. So V is V R1 plus E2 minus V by R2. So I is going to be equal to, I will cross multiply taking LCM. So E1 R2 minus V R2 plus E2 R2 minus V1 R2, the whole divided by R1 R2. So here there is an R1. Okay. This is also R1. Yeah. Here this is R1. R1. Okay. Now what will this be? I will cross multiply. So I into R1 R2 would be equal to E1 R2 plus E2 R1 minus, I'll take V common outside, R1 plus R2. VR1. Yeah. R1 plus R2. Now from this, it's very clear that this is the equation that I've just written down. Okay. This is this equation. Okay. So now what I will do, I will take V to the other side and I to this side because I want the formula in terms of V is equal to E minus IR. That is why I take V to the other side. So now what I will get, VR1 plus R2 is equal to E1R2 plus E2R1 minus IR1 R2. So V is equal to E1R2 plus E2R1 by R1 plus R2 minus IR1 R2 divided by R1 plus R2. So I divide the whole thing with this R1 and R2. Okay. So V is equal to this whole thing, I will write it as EP minus I into this whole thing, I'll write it as RP. So what is EP? EP is ER1 R2 plus E2 R1, that whole formula, and RP is R1 R2 divided by R1 plus R2. Okay. Yes, movies covered. Where are you from? Okay. Is this fine? So when you learn this, relate to these two. Learn these two together. Okay. And think of what are the differences here. Here you have V is equal to V1 plus V2. So you write all the formulas in terms of V. Here you have I is equal to I1 plus I2. So you write all the formulas in terms of I. And then the final formula only you make it in terms of V. Okay. Next question. Kirchhoff's junction rule. So what is the statement for Kirchhoff's junction rule? The sum of currents entering the junction is equal to sum of currents leaving the junction. So imagine I have 1, 2, and then 3, 4. Okay, 1 and 2 coming in, 3 and 4 going out. Okay, 1, 2, 3, 4. 1 and 2 coming in, 3 and 4 coming out. Then I1 plus I2 will be equal to I3 plus I4. Now here you can see I1 comes in, I2 also comes in, and then I3 is moving out. I1, I2 comes in, I3 moves out. So I1 plus I2 is equal to I3. So whichever direction it is moving, it will be either positive. If all the currents coming in you take as positive, then all the currents moving out you take it as negative. Okay. Another important thing, Kirchhoff's junction rule is the consequence of law of conservation of charges. Why? Because it just says that all the currents coming in are equal to the currents leaving, which means there is no current entering or leaving. Sorry, there is no current being created there. All the currents entering are equal to the currents leaving. That is what? Conservation of charge. Right. Now, don't by heart it. Think about it. What is Kirchhoff's junction rule? All the currents entering will definitely leave. And the amount of current entering and the amount of current leaving, it's the same. Which means charge is conserved. Right. There is no charge created anywhere. Whatever charge comes in, that many charge goes out. Conservation of charge. Okay. Okay. Now, Kirchhoff's loop rule or mesh rule. This just says that the algebraic sum of EMF and changes in potential around any closed loop in any electrical network is 0. Okay. So that is given by the formula sigma E plus sigma IR is equal to 0. Sum of all EMFs and sum of all potentials. But some of you might be thinking why potential is written as IR. Ohm's law students, V is equal to IR. So all potential, sum of all EMF E and all potential IR in a closed loop is always 0. IR is what? IR is just V. Okay? Okay. Very good movie ka world, right? Yeah. Good. Yeah. We have someone who's worked as an editor in movies. You all can, very good. I hope you finish your 12th with flying colors. Now, Kirchhoff's loop rule is the consequence of law of conservation of energy. Why? Because the total energy is the same. EMF and voltage together is always equal to 0. Okay? Yes. No. Can I have some fire emojis if you're all there with me? You will quickly put some fire in the chat. Okay. Next is the condition for balance of a Wheatstone's bridge using Kirchhoff's law. Okay. So first thing is figure. What's a Wheatstone's bridge? Wheatstone's bridge is when you have 4 resistors. Okay. Like this. 4 resistors. And I will put a galvanometer in the center. And I'll connect it. All the 4 resistors. I'll connect it to a battery. Okay. Yes. Okay. So if all 4 resistors are balanced, okay, which means there is nothing extra, they're all balanced, then the galvanometer will not show any deflection. Okay. Yes. So, okay, I will name this as A, B, C and D. Okay. Yeah. So let this be. I'll name the resistors as P, Q, R and S. Okay. Now what I will do, I will define current in purple or let's say pink. Okay. So the current through P, the first one I will take it as I1. The second one I will take it as I2. The third one I will take it as I3. Fourth one I will take it as I4. Okay. I1, I2, I3, I4. And the current through the galvanometer I will take it as IG. Okay. Yes. Yes. Now, what I will do, I will apply Kirchhoff's law. So first I will apply it on this loop ABDA. Okay. So first I will take the loop ABDA. Now I will start from here. Okay. So what I'm going to do, the convention that I'm going to use is, if I'm going in the direction of current, okay, then I will take that current as negative. Okay, all of you with me? So if I'm going forward and the current is in the forward direction, then it will be negative. So here I'm going to start from point A. Yeah. So I'm going to start from point A. So here you can see current is in my direction because I'm going from A to B. Current is also from A to B. So I will take that as negative. So the current there is I1, resistance is P. So minus I1P. Then I'm coming down. Through the galvanometer, I'm coming down. So here also current is in the direction in which I am going. I am going down, current is also going down. So this I will take it as minus Ig into G. Ig is the current in the galvanometer. G is the resistance of the galvanometer. Then I am moving to the next arm. So here you can see I am moving like this, but current is like this. Right? I am moving like this, current is like this. Two different directions. So that I will take it as positive. So this is plus I2. The resistance is named as R. Okay. Now this full loop is over. I came back to A. I started from A. I came back to A. Now this full loop, all the current and resistance together should be equal to 0. That is my equation 1. Is this clear to all of you? Yes? No? Excuse me? Can you all respond? Okay. I hope it's clear. Next, on applying KVL rule to the next loop, which is BCD. Okay. So I will erase this. The next loop I'm going to take is BCD. Okay. So I'm going to start from point B. And then I will come back all the way to point B. Okay. So I've drawn a similar figure on the other side. So you can look at the alphabets on that figure. Okay. So let me start from B. I'm starting from B. Okay, Nishu. Okay, I'm starting from B. Now, the first current is like, I'm going like this. Current is also in the same direction. So that is I3. Okay. So minus I3 and that resistor is Q. Minus I3Q. And then I go from C to D. Current is in the direction opposite to the direction in which I am coming. So that is going to be plus. And that current is I4. Plus I4 into S. Then I go this way. I go like this. But the galvanometer current is in the opposite direction. So again minus. No. It's on the opposite direction. So it's plus. So plus Ig into G. So this should also be equal to 0. Now this I and I4, I can write it in terms of I1 and I2. How can I do that? Let's look at that as well. So you can see I1, okay, and Ig. I1 and Ig. Whatever the current that reaches I3 is the difference between these two. Okay, so I1 comes, okay, let's say I1 is 10 ohms. Half of I1 goes to Ig, some of I1 goes to I3. Let me draw that for you. So I1 comes, it gets split into 2, Ig and I3. So what will I3 be? I1 minus Ig. You all agree? So I3 can be written as I1 minus Ig. Similarly, I2 comes, it gets split into, no, I2, okay, not that way. Yeah. I1 is correct. Now for I2 comes, Ig also comes. And these two together forms I3. Okay, I2 and IG together goes to I3. So what will I3 be? I2 plus IG. Okay, so there is I1, there is IG, there is I3. Let's talk about it individually. I3, it splits into IG and sorry, I1. Okay, I1 splits into IG and I3. So I3 is I1 minus IG. I2 and IG together forms I4. So I4 is I2 plus IG. So from this equation I3 and I4 I substituted in terms of I1 and IG. Now what I will do, I will take IG as 0. Why? Because I already mentioned. Yeah, because I already mentioned the current through a whole network, if the resistors are all balanced, then what happens? The current through the galvanometer is 0. The galvanometer will not show any deflection. So for balancing condition, Ig should be 0. So this term and this term is gone. So what remains? Minus I1P is equal to I2R and I1Q is I2S, because this Ig, both will be 0. All the Ig phases. Okay. Yeah. So these are the two numbers. I1P is equal to I2R, I1Q is I2. And then what you do? You divide equation 3 by equation 4. So when you divide equation 3 by equation 4, I1P is equal to I2R. So I1P by, and then I1Q is equal to I2S. And then you just divide it, you get P by Q is equal to R by S. This is the balancing condition. At this condition, galvanometer shows no deflection. Okay. Oh, so happy for you, Jennifer. Students, Jennifer has scored a very good rank in KCET. Okay, a rank of 1316 in KCET and 1285 in COMEDK by watching Vedantu Karnataka lectures. Very good, very good. So proud of you, Jennifer G. Jennifer, can you mention that in our comments as well? So, we get to know you and we can respond back to you. Okay, is this clear? So those of you who are confused, you can watch the recording of this video, pause it at every moment and think, okay, IG, I1, I3 and then do it. Okay, it's not going to be that difficult. Okay, let's move on to a very important next question is to derive the expression for magnetic field strength at any point on the axis of a current loop using Biot-Savart's law. Okay. Okay. Let's start. Who are you talking about, movies ka world? Who taught you without a smile? Okay. So for this question also, diagram is very important. So I don't know if I mentioned it for every question, but for most of the question, diagram is important. Okay, students, please draw diagram and then do the derivation. I don't want you to lose marks. So sometimes, you don't get marks for the derivation if you don't draw the diagram. So please draw the diagrams. Okay? Yeah. So here, we are going to find out the magnetic field of a circular loop. So this is the loop. Okay? I should have brought a wire, but I don't. Okay? So there's a loop. Okay? You're going to find out the magnetic field on the circular loop. So for that, what we're going to take is we're going to take one random point on the loop. Okay? So let's say this is the random point that I'm going to take. I'm going to take that small point on the loop. Okay? And I'm going to find out the magnetic field at a point P. Okay? So at a point P due to a small part of the loop. Okay, so this is the loop. I'm going to find out the magnetic field at one point P because of the loop. Okay. Yeah. Now, what else do you have to write? Yeah, current is in the downward direction. Now, this small element, I will take it as an element dl. Okay. It's an element dl for the whole loop. The distance from the center of the loop to point P is x. The radius of the loop is r. And the distance from point P to the length element, the small part of the loop that I took, that is my length element. That distance is r. Okay. That much is the loop. Now from point P. So point P experiences a magnetic field in a random direction dB. Okay. Now because dB is in a random direction, you have to divide it into x-axis and y-axis vectors. So if you have something in a random direction, you have to take the x-axis and y-axis and divide it. So the x-axis, the horizontal component is always the cos theta component, while this is always sin theta component. Okay. So this dB also I will resolve. It will be dB cos alpha and this will be dB sin alpha. Okay. Now, this is one part. Now, but you might be thinking, why take an element at the bottom of the ring? Isn't it? This is the loop. I'm taking dl on top. I can take dl on the bottom as well. So, if I take dl on the bottom, I will still have p here. Okay, let me erase this part and I will take dl at the bottom. Okay. So, if I take a small element dl here, from point P, this will be also at a distance r. This will have a magnetic field also along dB, but in this direction. So this will be dB for this dl. Now again, if I resolve it into horizontal and vertical components, there will be dB cos alpha and dB sin alpha in the downward direction. Okay, sin alpha, sin alpha. Now, the downward dB is because of the area element I am taking on the bottom. The other dB is because of the area element that I am taking on the top. I am just considering both. Okay. Now, since dB sin alpha and dB sin alpha, they're equal but they're in opposite directions, what happens? They will just cancel. Okay. So the dBs will cancel. So there is a dB sin alpha here as well. That will cancel. Okay. So magnetic field at point P due to current element AB is given by, magnetic field is given by dB is equal to mu 0 by 4 pi I dl sin theta by r square. Now, if theta is 90 degrees, sin 90 is 1. So, sin theta will cancel. The formula will be dB is equal to mu 0 by 4 pi I dl by r square. Yes, do you all agree with me? Okay. Now, let's do the mathematics. Now, y component of magnetic field will cancel out, but x component of magnetic fields are added up. That I already explained. Y components, one is in the upward direction, the other is in the downward direction. So, sin alpha will cancel. But x components, both are in the same direction. So, dB cos alpha because of the two magnetic fields. Okay. So, you have to add them up. So that is how you get the total magnetic field at point P. The total magnetic field at point P is basically the sum of the dB cos alphas. dB sin alphas cancel out. So they don't play a role here. Now what I will do, this dB value I already have. This is my equation for dB. Let me substitute that. So this becomes sigma. Instead of dB, I will write mu 0 by 4 pi I dl by r square cos alpha. Okay? Hi Suchitra. Okay. Now this is going to be equal to, I will take all the constants outside. So mu 0 by 4 pi I cos alpha by r square. See, all these terms are constant. In that figure, if you look, you can see all these terms are constant. They're not going to change. The only thing that you change is the dl, the length element. So sigma will belong to only the dl. Okay. Now, what is sigma of dl? Okay. So if you have the loop, I'm taking this much to be dl. So what is all the total length of the loop? Sigma dl is the total length of the loop. If this small part is sigma dl, then the full loop together will be 2 pi r. Isn't it? The full loop together will be 2 pi r. So instead of this sigma dl, now I can write it as 2 pi r. 4 pi I cos alpha by r square into 2 pi r. Okay? That is basically just like integral. You take a small element and then for the full element, it is the circumference of the circle. It is 2 pi r. Now you have this formula. Everything is clear. Now I'm going to take triangle POQ. Okay? So I'm going to take this triangle and I'm going to find out cos alpha. Okay? Too much yellow color. Okay? So I'm going to find out cos alpha from that triangle. So cos alpha will be, if this is alpha, cos alpha will be adjacent side by hypotenuse, which is going to be this one is written here. I will show that to you here as well. So cos alpha is going to be adjacent side by hypotenuse. So the adjacent side is what? The side closest, which is r. Hypotenuse is the slanting side, which is the side opposite to the 90-degree angle, which is r. So cos alpha so cos alpha is r by r. Okay. Now what I will do? This cos alpha, I will write it as r by r. Okay. So this is going to be equal to mu 0 by 4 pi 2 pi I r by r. So r square, the whole divided by r cube. Okay. Okay. 2 pi I by r square by r cube. This much clear? That's how I get this formula. I just substituted cos alpha as r by r. Now I will take the Pythagoras theorem. Let's go back to the figure. According to Pythagoras theorem, now let's erase this. Yeah. According to Pythagoras theorem, hypotenuse square is equal to side square plus x square. You all agree? Yeah. Now what I will do? I will take that here. So I will rearrange it such that r is equal to r square plus x square the whole raised to 1 by 2. And if I take r cube, what will it become? R square plus x square the raised to 3 by 2. I'll just cube both the sides. Okay. I'll cube both the sides. Now, what will my formula be? Instead of this r cube, I will write this. So the formula will become, okay, let me do that here itself. So the formula will become B is equal to mu 0 by 4 pi 2 pi I r square the whole divided by. Instead of small r cube, I will write r square plus x square the whole raised to 3 by 2. Okay? 2 pi I r square. Yes, perfect. Now this is for one turn. Now if there are n turns, I will just put an n here. That is how I get my final equation. I hope this is clear to all of you because I think I explained it properly. Okay, so those who are now confused now, I want you to watch after my live class is ended, after the class has ended, there will be a recording of the same live class. Go there, pause the video, understand each step and do it. Okay, I've explained each and every step, so it should be clear to you. Okay, yes, are we on the same team? Yes, or I am teaching, you are all sitting there and thinking what is happening here? Yes, can I have some thumbs up if we are on the same team? Okay, I'm getting so many requests to move my Monday's class to tomorrow itself. I will try my best. Okay, so tomorrow evening, if possible, I'll take the class on your request. Okay, because I'm taking it on your request, I want all of you to view the video. Okay, because the only thing that we will be able to continue with this channel only if you all watch the channel, right? Because that's the only kind of motivation we get, your support. So please tell all your friends to watch tomorrow's classes. So tomorrow morning 11, I have a class. If I have a very good number of students for that class, I will do the class in the evening as well. Agreed? Yeah. So it's your responsibility to share the link to all your friends and bring students. If the morning class goes well, evening also we'll have the class. Okay. Next question. Derive the expression for the force between two straight parallel conductors carrying current in the same direction and hence define ampere. Okay, not that difficult. Let's do it. So what does the question say? You have two conductors. You have two wires. Okay, there is current passing through the two wires. I1 and I2. Okay, and then there's magnetic field B2. Magnetic field B1, force F2, force F1. The distance between these two are B. Okay. Naveen the crazy, you will pass exam 3. Okay. Don't worry. You are all so tense. Don't worry. Okay. Now today after my class, what you should do is today night you sit. And whatever derivation I've done in class, you sit and write and study properly. Okay? Okay, and there are 2 more classes coming up. I want you to look at all of that. You will definitely pass. Okay, and after you pass, you should come and comment under my video and tell me that you have passed. Okay, because I want to know that. Yeah? You will pass. And I will be waiting for your comment that you have passed. Okay? Yeah. But I want you to study. Okay, next 2 days you should study. Only then you will pass. Don't come and tell me, ma'am, I watched your video and I didn't pass. Watch my video and study what is there in the video. Then you will pass. Yeah. Oh, I'm not sure, Lata. Can you talk to your PU college teachers and clarify that? I don't want to give you false information. Okay, so you have to talk to your teachers in college and clarify on that. I'm not very sure. Okay, so let's do this. Yeah, so we are going to derive the expression for two parallel straight capacitors. Right? Sorry. Conductors, not capacitors. So one wire, another wire, current passes through two wires. And current is in the same direction. So you can see I1 and I2 both are going up. So let's do the derivation. So magnetic field due to current I1. I1 is how much? First let's write down the magnetic field. I said magnetic field and I wrote current, right? I'm sorry. Yeah, I'm also like you, make mistakes. but I correct them. That's the important thing. Okay, so magnetic field is what? Magnetic field is B1. Magnetic field due to current I1 is B1. Students, I don't know if you know this. If you have a current carrying wire, this current carrying wire will always have a magnetic field around it. Okay, that's the property of a current carrying wire. So if you have random wire carrying current, it will always have a magnetic field around it. Okay, some of you might be wondering, there is no magnet here. Where is the magnetic field from? This is for some of you like that. But others are all smart. I mean, all of you are smart students. No discrimination. Okay, so magnetic field B1 is what? Nu 0 I1 divided by 2 pi d. Okay, 2 pi d is the distance between the wires. Next, the force on the segment on a segment L of a conductor Y is given by force F1 is what? Magnetic field B1, current I2, and then L sine theta. Very important. Okay. So if you have a current carrying wire I1, current carrying wire I2, okay, the force F1 will be because of I2. The force F2 will be because of I1. You understand that? These two current carrying wires will have forces on each other because of the current on each other. Too confusing? F1 will have current. F1 will have a force because of I2. F2 will have a force because of I1. That's all. Okay? Yeah. Now, if the theta is 90, sine 90 is 1. So, F1 will be B1. I2L, very important. Force on the current carrying wire is because of the current carrying wire on the side. Okay, I think I'm confusing all of you. So this is my I2. Okay, current I2 is passing through here. So this one will have a force because of this wire. So the force on I2 will be F1. The magnetic field will be B1. You understand that? I2 is the conductor current. I2 will have a force because of I1. So F1, it will have a magnetic field because of I1, B1. Okay? Yeah. Yeah. So F1 is B1, I2, L. Some of you are laughing in the chat. I can see that. Okay. Now, what I will do? I will add equations 1 and 2. This is my equation 1. This is my equation 2. Okay. So, if I combine the two, what will I get? F1 is equal to mu 0 I1 I2 L by 2 pi d. Okay. Similarly, if F1 is mu 0 I1 I2 L divided by 2 pi d, then F2 will be what? Mu 0 I1 I2 L divided by 2 pi d itself. Same thing. So, this is the force of attraction or repulsion. So, if the wires can attract or repel depending on the current in them and the charge on them. Okay? Yeah. Naveen the crazy, I bless you. Okay, Naveen wants my blessings for exam 3. So, I bless you, Naveen. Okay, I'll pray for all of you. Don't worry. Okay? Before your exam, I'll pray for all of you. And I just pray that next 3 days, you all have, the mindset to sit and study. So please uninstall Instagram if you can. No watching reels, sit and study. Okay? Yeah. Okay. Nishu, this is my job. Yeah? I am a teacher. I'm supposed to motivate all of you, right? I can't come and tell you, you will all fail. No. Because you will all pass. How can I say that? So you can see that even if the force is attractive or repulsive, the force is always mu 0 I1 I2 L divided by 2 pi d. So yeah, that is the derivation. Now in the derivation, there's also a part that says define an ampere. So let's do that as well. So ampere is a current which when flows through two infinitely long straight parallel conductors separated by a distance of 1 m 1 meter placed in free space causes a force of 2 into 10 raised to minus 7 Newton meter between them. Okay. So what I'm doing is in this formula, I'm just substituting everything is 1. Okay. So I take the two long parallel conductors as infinitely long. I take the distance between them as 1 meter and I say they're causing a force of 2 into 10 raised to minus 7 Newton. So that is 1 ampere. Yes, Smith. Samrita, is that your name, dear? You will all pass this time. Yeah, this time Isala cup will be all Namdus. Sorry, my Kannada is bad, so that's why I don't speak in Kannada. Okay, moving on. Powerfully moving on to the next question. How can a moving coil galvanometer be converted into a voltmeter? Explain with diagram. Explain with diagram. Yeah. So what is a diagram? Current is coming. There is a galvanometer. There is a resistor. So what is the answer? A galvanometer can be converted into a voltmeter by connecting a high resistance resistor in series. And which is this high resistance resistor? This one. Okay, very easy. You take a galvanometer, you connect a high resistance in series with it, you get voltmeter. Okay, so how will you remember this? Galvanometer, HRS, something like that. Okay, so voltmeter V will be what? Ig into G plus R. How did I get that? V is equal to IR, Ohm's law, everybody knows? Yes? Those who don't know, very bad. Okay, Ohm's law you should know. So V is equal to IR is Ohm's law. All of us know. Now what is the current here? The current coming in is IG. So current is IG. Now what is the total resistance? Resistance of the galvanometer plus resistance of the high resistance resistor. So that is how I get this formula. V is equal to IgG plus R. So from this, I will just rearrange. G plus R is V by Ig. So R is VIG minus G. Simple substitution. You are all very good in math. Right? Okay? Yeah. Students, if you can type in English, it would be better because I really can't understand very, this much. ಸ್ವಲ್ಪ ಅರ್ಥ ಆಗುತ್ತೆ. Okay? Yeah. So R is equal to V divided by Ig minus G. Clear? Next question is the opposite. How can you convert a galvanometer into an ammeter? Where is the space here? Into an ammeter. Okay? Thank you, dears Samrita. Okay? Yeah. So what we will do here, we have current I coming. You have a galvanometer. To this galvanometer, you are going to connect a low resistance in series. Okay. So to convert a galvanometer into an ammeter, you have to connect a low resistance in series. So that is the diagram here. So now let's write down the formula. Again, V is equal to IR. That I can understand. Movie ka world. V is equal to IR. Yes. These are all, previously asked questions. Hopefully, some of these questions will come. I also pray that all of these questions come. Okay. Yeah. V is equal to IR. V is equal to IR. So now, the potential difference across this resistor, this S, is what? The current in S times the resistance in S. Now, how much current is going to S? So, I is coming. Ig is going here. So, I minus Ig will go to S. Right? Yeah? I is coming. Ig is going to the galvanometer. I minus Ig will go to S. So V across S will be I minus Ig into the resistance is S. Now this should be equal to what? The potential difference in the galvanometer. So potential difference in the galvanometer is what? Ig into G. So when you equate the two, you will get this formula. So I minus Ig into S is equal to Ig into G. So from this, S is equal to Ig, G divided by I minus Ig. Very easy. Super easy. Harish Nikki has said that I hope it's a he, my classes helped him to get good grades. Thank you so much, Harish. So please let me know all this in the comments also, okay? Because live chat will be gone once the live class ends. So when I need motivation, I can go check the comment section and all these comments, they make me so happy. I see all the comments, okay? Yeah. Samrita, I already answered that, right? All of these will come. Next question. Expression for magnetic field at a point inside the current carrying solenoid. So the expression is B is equal to nu 0 Ni. The derivation I have not done here. In my next classes, I will do it. Yes, Harish, I will do numericals, okay? Tomorrow or day after tomorrow, I will definitely do numericals. Okay, let's look at the next question. Expression for magnetic force experienced by a charged particle moving in a uniform magnetic field. So the formula is F is equal to BQV sine theta. So F is equal to, this becomes Q times V cross B. Okay. Now there are two cases. In the question they can ask you, when will the force be maximum? Okay. So the question can be, when can the magnetic force experienced by a charged particle in a uniform magnetic field be maximum? When theta is 90, it will be minimum when theta is 0. Okay? Yes. Next question. Expression for force experienced by a current carrying conductor placed in a uniform magnetic field. F is equal to Bill. Okay. Bill. What is Bill? B-I-L sine theta. That can be written as I-L cross B. Okay. Students, did you all mark your attendance? Did you all like the video? Please go like the video and let me know that you're here. Okay. So if you like the video, I know. Okay. Mr. So-and-so has attended the class. Yeah. Okay. Next question. Expression for Lorentz force in vector form. So, what is the Lorentz force in vector form? Lorentz force is total force. QE and V cross B. Magnetic force and electric force. Okay. So, all this in detail in the derivations we will discuss. These are all important concepts. Next is the very famous Ampere-Circuital law. Okay. What does Ampere-Circuital law say that? Now, if you have a magnetic field around any closed path. Okay. So let's say you have a closed path and you have magnetic field. So the amount of magnetic field is equal to nu 0 times the net current in the path. So this integral is called closed integral. This is to show the surface is closed. Okay. This is the closed integral. And this closed integral into magnetic field times the area through which it is passing is always equal to mu 0 times the current through the surface. Okay? Yeah. That is Ampere-Circuital law. Now we will look at expression for magnetic field intensity due to a straight current carrying wire using Ampere-Circuital law. Aishwarya is asking me if exam 3 will be easy or difficult. See, I don't want to demotivate you and say it's going to be difficult, but usually exam 3 won't be that easy compared to exam 1 and exam 2, but things can change. There's no rule that it should be difficult or it should be easy. Just study whatever you have, pray, go give your best. Okay? Don't think it's going to be difficult. Now there's no time for you to think it's going to be difficult. Think that whatever you study in the next 3 days, you will be able to do well. Okay? You should think only like that. Just in your mind, set it. Next 3 days, I'm going to study very hard, and whatever I study, I will write properly, and the exam will be easy. Okay? That is the mindset that you should have now. Alright? Don't get tensed thinking it will be difficult. Because if you get tensed, you will not be able to study. Okay? So let's just think that it will be easy, but you have to study. Yeah? Okay. Now let's look at the amp. So for this derivation, we are going to start by Ampere's circuital law. Okay? So for Ampere's circuital law, we already learned Ampere's circuital law is B dot dl is equal to mu 0 I. Yeah? Now, this dl, I will write it as, it's a dot product. So this I can write it as integral of B dl cos theta. So cos theta, if theta is 0, cos 0 is 1. So I will ignore cos theta. So integral of B dl will be what? See, dl, as I always say, if this is a loop, dl is a small part of the loop. The integral of dl is the full loop, which is circumference. So this is b into 2 pi r. Okay, the integral sign won't be there. B into 2 pi r. So now what happens? I will substitute that here. B into 2 pi r will be mu 0 I. So B is mu 0 I by 2 pi r. Very easy. Yeah? Yeah, you'll say, ma'am, everything is easy for you, not for us. Everything is easy if you can study properly. Okay? I was also a student like all of you. I also did my PU. I know how, tensed it is and how much frustration you will have and all that. Okay, don't worry. Study properly. That's the only thing you should do. Get out of social media. Only use YouTube. Okay? And then study properly. Okay, in YouTube also, when you're watching Vedantu Karnataka physics, sometimes some of your recommendations will pop up. Watch this, watch that. No. Focus only in class. Okay? Yeah. Okay. Next is magnetism and matter. Let's look at magnetism and matter. So properties of magnetic field lines. What are the properties of magnetic field lines? Every magnet has a north pole and south pole. And field lines always start from the north pole. They go into the south pole. Okay? Field lines always start from north pole. They go in to the south pole. They go out of the north pole. Yeah? So you can see, they always form closed loops. They do not intersect with each other, okay? So here my drawing, they look like they intersect, but they do not, okay? So each loop is alone, okay? Now people who are following my class will know that I have a terrible handwriting, and by now all of you might have understood that I'm terrible at drawing. So that's why I put content, so you can refer that. Yeah? Yeah. Now they do not pass through superconductors. So what are superconductors? I don't think you need that information right now. Superconductors are conductors at very cold temperature. Okay, that much you know. They can pass through conductors and insulators, and the tangent drawn at any point in the field line represents the direction of magnetic field at that point. Okay, next, Gauss law in magnetism. So what is Gauss law in magnetism? The net magnetic flux through any closed surface is 0, which means if you have a surface, okay, if this is a surface, any field line that enters the surface will exit the surface as well. Okay, any field line that enters will exit. That means what? The magnetic flux through the surface is always 0. Why? Because entering is exiting. So it's like 0. In total, there is no field line. It's always 0. Whatever enters, exits. Yeah. So that is how you get integral B dot sigma or integral. Okay. Integral B dot, you can put integral B dot dA is equal to 0 also. Now, from Gauss law in magnetism, what is its significance? It signifies that magnetic monopoles don't exist. What does that mean? What a big term, no? But it's nothing. If that north pole cannot exist as north pole alone, a magnet will always have two poles. Okay. So let's say you have a magnet, north pole, south pole. I cut the magnet. Okay. Oh, I can move this. Okay, I didn't know this. Okay, I can move my. Okay, I can't. Okay, anyways. Now I cut this magnet. Now this piece of my magnet will also have a north pole and south pole. Now I cut this again. This small piece will also have a north pole and south pole. Okay, a magnet will always have a north pole and south pole. How many ever times you cut it? Okay, that is how magnetic field lines always, And how did, Gauss law prove that? See, magnetic field lines come out of the north pole, they go into the south pole. So if only north pole is there, magnetic field lines will only go out. Nothing will come in. Coming in is always through south pole. Since magnetic field lines always come in and go out, which is proven by Gauss, he also proves that monopoles don't exist. Okay? Yeah. Next is the properties of diamagnetic materials like a bar magnet. They are repelled by magnetic field, don't obey Curie's law, magnetization is low, relative permeability is less than 1, susceptibility is low and negative. Okay, for this also you can compare and learn. So in your book, what you should do is you should take a paper, write dia, para, ferro, and write down the points of all three. Okay, and then you compare. The first one, they are repelled by magnets. They are weakly attracted by magnets. Ferro, they are strongly attracted by magnets. First one, they do not obey Curie's law. They obey Curie's law. They obey Curie's law above Curie temperature. So write down the points, compare and learn. Okay, because all of them have similar points, right? So you might get confused. Yeah, we're all humans. Our brains have a capacity. So we will get confused. So what you do is you write it down, compare and study. Okay? Yeah. So these are all tricks that I used when I was a student. So I hope you guys also find these helpful. Harish, I will upload this PDF in the Telegram chat. So you will have to join our Vedantu Karnataka Telegram channel to get these notes because that's the only way I can upload it. That's why. Okay? Yeah. I understand, Harish. It will be helpful for last minute revision. Yes. Okay, next chapter, electromagnetic induction. So, first we will learn the Faraday's law of electromagnetic induction. So, the magnitude of induced EMF in a circuit is directly proportional to the rate of magnetic flux linked with the circuit. So, induced EMF, the amount of induced EMF is going to be equal to minus N is the number of how many ever loops are there into the magnetic rate of change of magnetic flux d phi by dt. Okay? Yes. Yeah. So EMF induced E will be equal to minus N d phi by dt. Next is Faraday's law. So this is an experiment done by Faraday and Henry. This experiment was to study electromagnetic induction. Okay. So the magnet, there's a magnet, there's a coil. This coil has current passing through it. Okay. And yeah, this coil is connected to a galvanometer. So the galvanometer deflects when there is a change in magnetic field or change in current and all that. So when the north pole of the magnet is pushed towards the coil, the galvanometer shows sudden deflection in one direction. That means inside the coil at that point there is a current induced. Now, when the magnet is brought out, because this is the coil, magnet is brought in, galvanometer shows deflection, the magnet is brought out, it's resting, then the galvanometer does not show deflection. Now, when the magnet is pulled away from the coil, the galvanometer shows deflection in the opposite direction. This indicates that current is induced in the opposite direction. So it's a very simple process. You have a magnet, you bring it close to the coil. What happens? The galvanometer, let's say, deflects in this direction. When you move it out, galvanometer deflects in the opposite direction. When the magnet is at rest, galvanometer does not deflect. That's all. Okay. Now, this also depends on the pole. So if the north pole is brought, galvanometer deflects in one direction. When the south pole is moved, the galvanometer deflects in the opposite direction as compared to the deflection in the north pole. Okay. Yeah. Now the deflection of the galvanometer is large when the magnet moves faster towards or away from the coil. So if I move it fast, very fast, then what happens? The galvanometer deflection will be large. Now if the coil is the same thing, the current being induced, it can be done if the magnet is still and the coil is moving. So in the first part I explained when the coil is still and the magnet is moving. Now if the magnet is still and the coil is moving, same effect occurs. When it moves towards, it will have deflection. When it moves away also, it will have deflection. Okay, next. Derive an expression for motional EMF induced in a conductor moving perpendicular to the magnetic field, to uniform magnetic field. Okay? Yeah. So, imagine you have a conductor like this. Okay? And this is, what is this? Something that can move. Okay? A wire or a rod that can move. So the magnetic flux in the loop PQRS, this is PQRS. Okay? So in PQRS, the magnetic flux phi is B into A. Okay? Now what is B into A? A is the area. This is a rectangle. What is the area of a rectangle? Side into side or length into breadth. So this length is L and this length is L and this breadth is X. So this becomes B times Lx. Now we already know induced EMF E is minus d phi by dt. So E is equal to minus d into phi. I'll replace it with Blx by dt. But we also know that dx by dt is minus v. So what happens? This becomes E is equal to BLV. Okay? E is equal to BLV. Very easy. Yeah. Okay. Next is the Lenz's law. So Lenz's law is a consequence of law of conservation of energy and it gives the polarity of induced EMF. Okay. So let's find out the expression for self-inductance of a solenoid. I mean, we are not finding out here. Here I've just written down the expressions. So what is the expression? L is equal to mu 0 mu r n square AL. So all of these expressions, students, when you write, depending on the marks, you have to explain the terms as well. So if it's a 2-mark question and you simply write L is mu 0 mu r n square AL, you won't get full marks. You have to say mu 0 is permeability of free space. Mu r is relative permeability of core. N is number of turns. Small n is number of turns per unit length of the solenoid. A is cross section of the solenoid. L is length of the solenoid. So you have to explain the terms. Now for mutual inductance, how does this formula vary? For mutual inductance M, this formula becomes mu 0 mu r same. N square will become N1 and N2. That's the only difference. Okay. That's because in self-inductance, this is one coil. Mutual inductance is 2 coils. So N1 and N2. Okay. Yes. Okay. Next is the next chapter, which is alternating current. Okay, students. We'll just have a 5-minute break. I just need to, drink some water. Okay. So I will just quickly come back. All of you who want to have your dinner, you can have it. I will just come back in at 9:20. 12. Okay? Yes? Okay. So quickly you can all go eat. Yeah? Are you all enjoying the class? What a question, right? Who enjoys physics is what you're asking me back, I know. Okay, yeah. I'll be back at 9:12. Hello. Everybody left the class. Yes, Asha. I don't know. Where did everybody go? Okay, I have 7 people now. Where are my other students? Students, all of you, please do like, subscribe, and share this with all your friends so we can keep doing this. Okay, doing this as in keep doing videos. Because if we don't have people watching, then we won't be able to continue. Okay, let's look at alternating current. So transformer is the first thing that we'll be looking. What is transformer? It is a device that is used to step up or step down alternating voltage. So current is generated in power stations, and from there, your current has to travel a long distance to reach your house. So when traveling this long distance, what the power stations do is they increase the value of voltage and decrease the value of current, but maintain the same power. So power is VI. So what they do is they maintain the same power, but they increase voltage and reduce current. Why? Because if high current passes, it will produce heating and lots of current will be lost. So you have you have a transformer there to increase voltage, reduce current. And then when it reaches somewhere near your house, you've seen transformers on roads, right? Those transformers will reduce the voltage, increase the current, like the actual value, and send it to your households. Okay? So that is why there is a step down and step up. Hi Praveen. Okay. Now what is the main principle of a transformer? It's mutual induction. How can you construct a transformer? You can construct a transformer by using a soft iron core. Okay. So you have a soft iron core. You have coils here. You have more coils here. I mean, it depends on the transformer. For step down and step up, the number of coils on the primary and secondary will keep changing. Now this is connected to an input, AC input. This is connected to the output. This core is a soft iron core. Okay. Now the different energy losses in transformers. Energy loss due to heating, loss due to flux leakage, loss due to eddy currents, loss due to hysteresis. And phase angle between voltage and current in if it's a pure resistive circuit, it's 0. If it's a pure inductive, it's 90. If it's a pure capacitive, it's 90. If it's a pure resonant circuit, it's 0. Okay. I'm good, Praveen. How are you? So, students, in this video, I'm not discussing any 5-marker very long. I have discussed some, but I'm not discussing everything in depth. So, I will do that in the next 2 classes. Okay. Next is the expression for displacement current. What is the expression for displacement current? ID is epsilon d phi E by dt. Epsilon naught is the permittivity of free space. d phi by dt is the rate of change of electric flux. Now, what is the difference between displacement current and conduction current? So, conduction current, it is due to flow of actual charges. Normal current. What is current? Flow of charges. But displacement current, there is no actual charge flowing. But electric field is changing, so there is a current being generated. That's all. But actual charge is not moving. So if you have 2 capacitive plates, charge is not moving from one to another. Because of the change in electric field, there is a current. So that current is displacement current. So the difference in all of that, you can check out. Next is the expression for speed of electromagnetic waves in free space. Speed is what? C is equal to 1 by square root of nu naught epsilon naught. Students, is there disturbance? Are you getting disturbed? Because I can hear a lot of vehicles passing by. Are you also able to hear it? I'm really sorry for that disturbance because it's, just 9:17 and, people are there everywhere. Okay, next is expression for electromagnetic waves in a material medium. So what happens? The speed becomes 1 by square root of nu into epsilon. Okay, so this is the same as C root of nu r epsilon r. Yeah. Yes, Samarth. Tomorrow's class is important. 2 markers, 5 markers and 3 markers. Okay? Okay? Yes? Yeah. Okay. Next. For long to short wavelength, the electromagnetic spectrum is of this order. So this is from long to short wavelength. So like this. Like this. So the longest is radio, then micro, infrared, visible, UV, X-ray, gamma ray. It just keeps on going like that. Okay. Next chapter, rays and optical instruments. You know the laws of reflection. Very important. What are the different laws of reflection? Okay. Yeah. First one is the law of reflection. Okay. Value of mu naught. You've itself given the, yeah, it's 4 pi into 10 raised to minus 7. Yeah. Okay. So first law of reflection is, if you have a surface, this is, let's say this is a mirror, this is a reflecting surface. Yes, correct, Praveen, that's correct. So this is a surface, this is a normal, you have an incident ray, you have a reflected ray. So the angle of incidence and the angle of reflection should always be the same. I is equal to R. Next point, incident ray, reflected ray and normal, all three should be lying on the same plane. Okay. Now, there are some sign conventions in ray optics. So that's very important. So if you have a mirror or a lens or whatever, all the measurements are taken from the center, which is the pole. Okay. First thing you need to know, all the measurements are taken from the pole. Okay. Now, if this is the direction in which the incident light comes, and the let's say this is the focus. Okay. Now, if the measurements are taken in the direction of the incident light, then it is taken as positive. In the direction of incident light, it is taken as positive. Now, if it is measured in the direction opposite to that incident light, it is taken as negative. Now, for example, this is the focus. Measurements are always starting from the pole. So, from pole to focus, it's in the direction opposite to incident light. Or you can say it's in the left direction. It is going to be negative. But if I have a focus here, this is taken as positive. Okay. So, anything in this direction is positive. In this direction is negative. Okay. Now, if you measure anything towards the top, then it's positive. Towards the bottom is negative. For example, let's say you have, let's say you have an object here. Okay. The height of the object is going to be positive. But let's say you have an image here. The image is going to be negative because it's measured downwards. Okay. So that is what is here. Anything measured upward or downward will be positive and negative. Okay. Yeah. Praveen is so concerned about how I look. Thank you for your concern, Praveen, but it's okay. It's just important that you understand what I teach. That's the most important thing. And I hope you are understanding. Okay. So this from the pole in this direction, negative, in this direction, positive, in the upward direction, positive, in the downward direction, negative. Okay. Yeah. Next. Relationship between focal length and radius of curvature, or show that R is equal to 2F. Okay, so you have a mirror. Okay, you have an incident ray coming in. You have the incident rays reflected through the focus. Okay, this is the condition. Incident ray coming, reflected ray passes through focus. Yeah. Okay, now the center passes, through the center there is a normal. So what we will do, C, F, P, and then M. Okay. Now first thing is the angle between the, so I will draw it bigger here. So this is how it is, right? This is the normal. This is theta. This should also be theta. Why? Because angle of incidence and angle of reflection should be the same. Now this is the principal axis, okay? Yeah. Now, if you look at these are alternate angles. So if these two are theta and theta, this should be 2 theta. Okay? Theta and theta, this should be 2 theta. Yeah. Now, M, C, F, and then this is the pole. Okay? So first what we take is, we take triangle MCP. MCP. This will also be theta, alternate angles. So this angle is theta, this angle should also be theta. Now if you take MFP, MFP is 2 theta, that also I explained how. Now if you take tan theta, what is tan theta going to be? MD by CD, MD, okay, this is D. Yeah, MD by CD. So this is the triangle that is taken, this big triangle. So tan theta is opposite by adjacent, MD by CD. Tan 2 theta is MD by FD, taking the small triangle. So that is taking the big triangle, and then the next one is taking this small triangle. Okay, big triangle and small triangle. Okay. So then what I do is, you take the angle to be very small. Okay, so tan theta is very small. So tan theta becomes theta. Tan 2 theta becomes 2 theta. So you will get theta is equal to MD by CD divided by 2 theta is equal to MD by FD. So tan terms I neglect. Now what I will do, I will just equate the two. So this MD by CD, can't I write it as, see, theta is equal to MD by CD. So can't I write it as 2 theta is equal to 2 MD by CD? Yeah. So that is what I have done here. 2 MD by CD is equal to MD by FD. And then I cancel MD. 2 by CD is equal to 1 by FD. What is CD? CD is the radius of curvature. And then FD is the focal length. So this becomes F is equal to R by 2. Okay? Yes, no. So this will be theta. Alternate angles. Okay, next is the laws of refraction. So what are the laws of refraction? Again, the refracted ray, normal, incident ray, they all lie on the same plane. Now the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. So you have sine I divided by sine R is equal to constant. Okay, and this is also the very famous Snell's law. It's also called as sine law. Okay, next is total internal reflection. Students, can I have some energy? Yeah, can you all put some fire emojis in the chat so I get some energy from all of you? Yeah. No, it's not uploaded. I know. I will up. Sorry. Yeah. Okay. So next is total internal reflection. Yeah. So for total internal reflection, you have a plane. Okay. So depending on the angle of incidence, the angle of refraction will keep on changing. So you can see here the incident ray is at an angle greater than an angle called critical angle. Then it just refracts like this. In the second case, it is equal to critical angle, then the refracted ray will be parallel to the surface. So what is critical angle? Critical angle is that angle of incidence which makes the refracted ray parallel or 90-degree with respect to the normal. It will be 90-degree with respect to normal or parallel to the axis. Now, what is the last one? I will be greater than critical angle. Now, if the incident ray is having a value greater than critical angle, then what happens? It will be reflected into the surface. It wouldn't go out. See, this is when you have a glass. Man, you have two surfaces like a glass and water. So the ray that is passing through the glass, if the angle is greater than critical angle, it wouldn't come out of the glass. It will stay inside the glass. So this is used in optical fibers. So there are some fibers that allow light to pass through. So light just passes through it like this. Continuously passes through it. It doesn't move out. Okay? Yeah. Thank you, Sai and Steve, for that fire. Okay. Now, conditions for total internal reflection. The first one, the ray of light must travel from an optically denser medium into a rarer medium, like glass to air. Okay. So, the medium in which the incident light is should be denser than the medium outside, or glass and air. That's what I said. Yeah, or water and air, anything like that. Now, the angle of incidence in the denser medium must be greater than critical angle. Okay? Yes. Now, critical angle for a given pair of medium is that angle of incidence in which, I already explained this. Total internal reflection also I already explained. Now, relation between critical angle and refractive index. So, we already know what is Snell's law. N1 sine I is equal to N2 sine R. Now, Sri also has put fire emojis. Yeah. Friends, students, your friends also. All of you send this to all your friends who are writing exam 3. Okay, and tell them, please prepare very well and this time score very well. This is your last and final chance. I hope you all have that in your mind. I'm not saying this to scare you, but don't waste your time now. Okay, this is your last and final chance. Let's just finish it with a bang. Okay, yes. Just like RCB 1, you will all finish it with a bang this time. So let's say N2 is 1 and N1 is N. Okay? Yeah, Sri already sent the video link to all her friends. Very good, Sri. So imagine, so for this to happen, okay, for this, refraction to happen, the incident ray should be equal to critical angle and the refracted ray or reflected ray, whatever, it should be equal to 90-degree. So we already know this is a formula. N1 sin I is equal to N2 sin R. So N1, I will take it as N. Sin I will take it as sin C. Should be equal to N2 is 1 into sin 90. So sin 90 is 1. So what happens? Sin C is 1 by N. 1 by N. Okay? Yeah. Next is the power of a lens. Power P is equal to 1 by F. And the SI unit of power of a lens is diopter. Okay. Next question is the expression for equivalent focal length for two lenses in contact. So if you have two lenses that are in contact, then the total focal length of both the lenses together. So lens makers formula, okay, that also is very important. So lens formula, what is lens formula? 1 by V minus 1 by U is equal to 1 by F. Very important. So for the first lens, it will be 1 by V1 minus 1 by U is equal to 1 by F1. Okay. Now for the second lens, the formula will be 1 by V minus, instead of U, it will be V1. This is 1 by F. Now, how did I get that? So, this V1 means that if one lens was alone, okay, if one lens was alone, there will be an object and an image. Now, this image is now reflected again by the second lens. So, this image from the first lens acts as an object for the second lens. Okay, that is why U of the second lens is V1, which is the image of the first lens. Okay, now you just equate it. You will get 1 by V minus 1 by U is equal to 1 by F1 plus F2, and 1 by V minus 1 by U is equal to 1 by F. Now combining the equations, you will get 1 by F is 1 by F1 plus 1 by F2. So if you have two lenses in contact, the focal length of the two lenses is 1 by F1 plus 1 by F2. If you have three lenses, the total focal length is 1 by F1 plus 1 by F2 plus 1 by F3, blah 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 blah. Okay, so how many ever lenses you have? The total focal length is the sum of all of those together. Okay, yes, no. Okay, next is wave optics. Okay, so wave optics. Yeah. So what happens? You have a surface. Okay. First question is the reflection of plane wavefront using Huygens principle. So you have a surface, you have an incident ray, okay? You have a reflected ray. Now you have another incident ray, and that is also reflected. So what I will do is I will join these two incident rays, okay? The two incident rays, and I will get something called as my incident wave front. So a wave front is a group of waves. Okay. So if I have 2 or 3 waves and I draw lines on these waves such that on the line all 3 waves have the same phase and same properties, then that is the incident wave front. Okay. Yeah. So now this is the incident wavefront. Now this is a line that is joining all the reflected rays. So I will draw another line joining all the reflected rays. This is one reflected ray. Let's say there's another reflected ray here. So this is my reflected wave fronts. Okay. Okay. Yeah. So let V be the speed of light in the medium in triangles ABC and DCA. ABC and CDA, it's 90 degree. BC, AD, BC and AD. Where is BC? Yeah. This is V tau. V tau is the velocity. T is the time taken. See, the 3 videos that I'm going to do, they're not going to be very different things. Okay, you don't have to get scared. So in this video, I've talked about all the chapters. The same chapters in little more, I'll make it as questions. Okay, so whatever we discussed today, you will have 2 markers, 3 markers, 5 markers in the next class. It's not going to be all different because you have only one textbook. Okay, don't worry, relax. Okay, and the last class will be mainly numericals. Okay. Okay. My God, students, you're all. See, now I have not told you what is what marks and all that. In the next class, I'll tell you these are 2 markers, 3 markers, 5 markers, and all that. Okay. Now the triangles ABC, DCA are congruent. Yeah, all of this is just simple things. So here the main thing is you have to prove that angle I is equal to angle R. Now the same thing you can do for refraction. Okay. So for refraction, the diagram will be different. Rays will pass through a medium. So this is medium 1. This is medium 2. So you have one ray coming, the second ray coming. This ray is refracted. This ray is also refracted. Now I will join the two incident rays. Okay. I will get my incident wavefront. I'll join the two refracted rays. I get my refracted wavefront. Okay. Okay. Yeah. So the incident plane wavefront is AB. XY is the refracting surface. AD is the refracted plane wavefront. Now BAC. BAC is angle I. DCA. DCA. This is angle R. So this is the incident angle and refracted angle of the wavefronts. Not for the wave, but for the wavefronts. Okay. Now BC, this is V1 tau T, and then AD, this is V2 T. Okay, V1 T, V2 T. Now for the first triangle BAC, the top triangle, you will get sin I is equal to DC by AC. Now in the second triangle, you will get sin R is equal to AD by AC, and then when you divide it, you will get this. So BC and AD, you know, it's V1T, V2T, you divide it, you get V1 by V2. So from this, you will get N2 by N1 is equal to V1 by V2. So sin I by sin R is N2 by N1. So therefore, you will get N1 sin I is equal to N2 sin R. This is the famous Snell's law of refraction. I will erase this so that when I upload it, you are able to see it all clearly. Okay. Let's move on. Now, these are some conditions for interference of light. So, the modification. So, what is interference? When two or more light waves superimpose together, that is interference. For constructive interference, the phase difference is 2n pi, path difference is n lambda. So, lambda, which is wavelength of light, it is n 0, 1, 2, 3. Okay. For destructive interference, the phase difference is 2n plus 1 pi, path difference is 2n plus 1 lambda by 2. These are all things you can learn straightforward. Okay. Yeah. Next is the difference between interference and diffraction. What is interference? What is diffraction? So what is interference? Yeah. What was funny now? If you're smiling. Okay. What is interference? When intensity of all bright fringes are equal. Diffraction is when intensity of all bright fringes are not equal. Number of fringes observed more. Okay. So let me show you that. So you have a wave. You have another wave. When they interfere, you get a big wave. Okay. And all the bright fringes. So this is how the wave will be. All the fringes will have the same, bright fringes will be bright, high, dark fringes will be low. But for this thing, diffraction, what happens? It's like this. So that it's not same. I don't give up, mama. Do you mean ma'am? Okay. Okay, let's move on. Students, I've been talking for how many hours now? I'm very tired, but still, because you have exams and I want you to score well, I'm doing this. Okay? So I expect all of you to study well. That's the only thing I expect. Please study well and score well for your exam 3. And after your exam 3, you should come and tell me in the comments that it was good. I want to hear that. Okay? Yeah. So now there is something called Polaroids. Okay? So that is not fully there in the syllabus. You only need to know the uses and Malus law. So, your sunglass. When you wear your sunglass, you don't see all of the sunlight. Right? You can look at the sun with your sunglass. That's because it cuts one set of light ray. Only the rest of the light ray reaches your eye. So, Polaroids are used for that, to polarize light. Okay? So they're used to view 3D pictures, sunglasses, windows of vehicles, and all of that. Now, Maller's law. So Maller's law states that if you have, a polarizer, the intensity of light passing through the polarizer, and then you have an analyzer. So analyzer analyzes the polarized light. Okay. So this is the light that's coming in. After it comes out of the polarizer, it becomes like this. And then there's an analyzer. So the light coming out, the intensity of light will be I0 cos square theta. Okay. It's going to be I is equal to I0 cos square theta, where I0 is the intensity of unpolarized light. So the total polarized light coming out will be equal to the amount of unpolarized light into cos square theta. Okay. Yes. No. Okay, we are at chapter 11, dual nature of radiation and matter. So probably by 10 o'clock or 10:15 we can finish this chapter. This video. So in this chapter, you need to know about the different types of electron emissions. So what are the different types of electron emissions? There's thermionic emission, photo emission, field emission, and secondary emission. Okay. Now, the different laws of photoelectric effect. First one, what happens? Radiation comes and hits a metal surface, electrons are ejected. This is an instantaneous process, right? So the ray does not go and hit and then after 1 hour, electrons are emitted. No. So photoelectron emission is an instantaneous process. Now, for a given metal, there exists this minimum frequency of the incident radiation for which photoelectron emission has to take place. If this is the metal, the radiation that's falling on the metal should be of a certain frequency which is higher than the threshold. Only then it can eject electron. So if a very low frequency radiation falls on it, it cannot emit an electron. It should be above the threshold frequency. Okay. Now above the threshold, now if it is above the threshold frequency, the photoelectric current. So photoelectric current is directly proportional to the intensity of incident radiation. Okay. Next is above the threshold, the maximum kinetic energy of photoelectron is directly proportional to frequency. So that is above threshold frequency. Kinetic energy is proportional to frequency. Photoelectric current becomes zero at a particular voltage called stopping potential. Okay. At stopping potential, photoelectric current is zero. Above threshold frequency, stopping potential is directly proportional to frequency of incident radiation. Okay? Yes? Okay, next is Einstein's explanation of photoelectric effect. So Einstein said that, if the radiation comes, some of the energy from the radiation is used to knock out an electron, which is called the work function. The rest of the energy is used up as kinetic energy. So what will kinetic energy be? The difference between the energy of the incident radiation and the amount of energy taken away by the electron. So that will be kinetic energy. So radiation comes, half of it is used to take electron, the rest is kinetic energy. That's all. Okay? Yeah. Next, it's just the explanation. Same thing. Instantaneous process. Now, if V is equal to V0, kinetic energy is 0. Why? So, high intensity radiation comes. All of this energy is used up to knock out an electron. Then there is no kinetic energy because the rest of the energy is what is converted into kinetic. So, kinetic energy won't be there. So, photoelectric effect is not possible. Okay? So, only if the radiation coming in has enough energy to knock out the electron and the rest of the energy is given as kinetic energy. Kinetic energy is positive, photoelectric effect is possible. Okay? Photoelectric effect is not possible in any other way. All this we discussed already. Next is properties of photons. So photons, the rest mass of a photon is 0. Okay? Now for all photons travel with the same speed, which is the speed of light. and they all travel in the same line. Photons won't travel like this, like honeybees. They always travel in a straight line, and photons have no charge. They are not positive nor negative. They are neutral. And each photon has an energy E is equal to h nu. Okay? Photons are not deflected by electric or magnetic field. Why? Because they are neutral. How will they be deflected by electric or magnetic field? Okay, let's look at the next topic, which is de Broglie waves or matter waves. So these are waves associated with any moving particle. Okay, now these are some expressions for de Broglie wavelength. It's good if you can learn them. Yeah, tension. No, it's very easy. So de Broglie wavelength is what? H by mv. But lambda in terms of momentum, what is momentum? M into V. So in terms of momentum, H by P. In terms of kinetic energy is what? Half mv square. So this becomes H divided by root of 2m k. In terms of voltage, it becomes 2m q d. Okay? Yes? Hello Tarun. Hello Sai Manjunath. Are you all ready for exam 3? Next chapter, chapter 12, atoms. Okay, some of you might already have stopped. Like, ma'am, I'm only learning this much. Bye, ma'am, I'm leaving. No? Okay. So first one is the alpha scattering experiment. Okay. So you have alpha particles. What are alpha particles? So alpha particles are helium particles. Okay. They're helium nucleuses. So they have 2 protons and 2 neutrons. They do not have electrons. So because it's the helium nucleus. Okay. Alpha particle is similar to helium nucleus. So that is why alpha particles are positive. Okay. First thing to remember, alpha particles have 2 protons and 2 neutrons. So they are positive particles. So these alpha particles will go, it will hit the gold foil. Okay, it will hit the gold foil. So this gold foil has a lot of atoms. It has atoms. Gold foil has atoms. Atoms have protons, neutrons and electrons. So this proton part is coming. Proton positive alpha particle is coming. It's hitting the gold foil atom. If it is hitting the nucleus, it will be deflected back. Positive. If it is coming somewhere near the nucleus, it will go like this. If it is passing through the empty space, it will just go straight. Okay? Yeah. So you can see some of the particles, they go straight. Some are deflected. Some are deflected back. So this experiment helped prove the structure of an atom. That the atom has a lot of empty space. Atom has positive nucleus, which is very small because very few particles were deflected back. Okay. So this was the first experiment that helped us find out the first basic structure of atom. And then Bohr came up with Bohr's atomic model and he gave his postulates. Okay. Okay. So the first point is what? The first postulate that Bohr gave is that electrons revolve in orbits. All of you know this, right? Now you all know because these scientists did all these experiments and found that out. Okay. So Bohr was the first person to explain that electrons move in orbits and the angular momentum of each orbit is L is equal to NH by 2 pi. Okay. And these are the orbits. Okay. Imagine these are the orbits. There's an electron here. Okay. So this electron, can you see this? Yeah. So this electron, it gains some energy. Some particle hits it, it gains some energy. Now this electron is like, I'm fully confident. I can go to the next energy level. Why should I just stay here? And what happens? He goes to the next energy level. But once he reaches there, he realizes he does not have enough energy to stay there forever. He has to go back home. Because he just got some energy with that, he moved up, but he cannot stay there forever. So he comes back and on his way back, whatever extra energy he has, he will emit it out because he does not need that in the lower energy level. Okay. So this emitted energy, h nu, is what? The energy difference between the two orbits, which is, this is E1, this is E2. E2 is higher, so E2 minus E1 will be emitted out as h nu. Okay, do you understand this? Yes. Okay. Yes, yes, Vishal. You didn't have fire emojis, no? I remember you. Okay. Thank you, Sri. It tells me the class is interesting. Comments like that motivate me. Thank you so much. Okay. Next is limitations of Bohr's theory. So Bohr gave, that theory, three postulates he gave. Now he gave some drawbacks. I mean, he didn't give, but other scientists found out drawbacks in his theory. What were the drawbacks? Bohr's theory is applicable only to hydrogen and hydrogen-like atoms. It's not applicable to anything else. It does not explain the fine structure of spectral lines. It does not explain effects like Stark effect, Zeeman effect, and it does not explain the wave nature of electrons. Okay, so I can explain each one of this in detail, but you don't need that at this point of time. Okay, so let's just not waste time. If you do physics in your, higher classes, you will learn all this. Higher classes as in your degree and all that. Okay, next is the expression for energy of an electron in nth Bohr orbit of hydrogen atom by assuming the expression for radius. So the total energy is what? Kinetic energy plus potential energy. Yeah. Now, electrons move in circular orbits, right? So if electron moves in circular orbit, they have centripetal force. So it is mv square by r. Yeah. And this is also equal to the electrostatic force, which is 1 by 4 pi epsilon naught Ze square by r square. Now you have a keyboard, Vishal. Are you on your phone? You're putting fire emojis. Okay. So yeah. So for something to move in a circular orbit, the centripetal force should be equal to the electrostatic force. So now what I will do is I will divide both sides by 2. Okay. So r and r square will cancel off. Then I divide both sides by 2. So what will I get? mv square by 2 is equal to 1 by epsilon naught Ze square by 2r. So I will just put this as 8. Okay. 2, I will put this as 8. So now what I will get, I will rearrange this whole thing and I will get, I don't rearrange anything. mv square by 2 is what? Kinetic energy. Yeah. So I get kinetic energy as Ze square by 8 pi epsilon naught r. Yeah, mv square by 2, I read it as kinetic energy. Now potential energy is what? 1 by 4 pi epsilon naught Ze into E minus r. Sorry, divided by r. Okay. Good, Vishal. Okay. So now potential energy is minus Ze square 4 pi epsilon naught r. Okay, epsilon naught is not visible here. I will just fill it up. Yeah, epsilon naught by r. So now what I will do? I will just add kinetic energy and potential energy. So since there's a negative sign, there's a negative sign here, and I take all the common terms out. What are the common terms? Ze square divided by 4 pi epsilon naught r is common. What remains? 1 by 2 minus 1, which is minus this. Okay. Now, 8 pi epsilon naught, the radius I substitute it. Okay. So there is, from here, you equate r. So mv square is equal to 1 by 4 pi epsilon naught Ze square. From there, you find out r and you substitute it here. Okay. Exactly, not from there, but that derivation I have not included in this. I will include it in my next class. Okay. So you get the value of r and then you just equate it. Now for hydrogen atom when Z is 1, you remove Z. So what remains is En is equal to minus me raised to 4, 8 epsilon naught n square x square. Okay. Thank you, Shreyas, for your request. I drank water. Okay. I'm good. Thank you for your concern. It really, really means a lot. Yeah. For all this effort, the only thing I wanted in return is all of you should do well in your exam 3. Okay. And you should come and comment under my video and tell me how it was. Otherwise, how would I know? Yeah. Yeah. Okay. Now this is the energy level diagram of hydrogen atom. So N is equal to 1, 2, 3, 4, 5, 6 in this Lyman, Balmer, Paskin, bracket and Fun. So Lyman is when all the energy levels fall onto N is equal to 1. Balmer is when from whichever energy level it falls to N is equal to 2. Paskin is bracket is when from whichever levels it falls to N is equal to 4. Okay. Now, in Lyman, you have UV region. In Balmer, it's visible. In Paskin, it's infrared. In bracket also, it's infrared. For Fun series, also, it's an infrared. Okay. Yes. Next is de Broglie explanation of Bohr's quantization rule. So, for a stable orbit, okay, for a stable orbit is circular. So, it's equal to the circumference 2 pi r should be equal to integral multiples of lambda. Okay. So, 2 pi r is n lambda. So, what should lambda be? From this we already learned. De Broglie wavelength is h by mv. Okay. So, n lambda will be nh by mv. This is what? 2 pi r. Okay. So, from this you will get mvr is nh by 2 pi, which is the Bohr's quantization condition or the angular momentum condition. Okay. Yes, Harish, I understand. I will send it today after class. Okay. Yeah. Okay. Next is nucleus. So in nucleus, it's just the binding energy curve and all that. This is all not that, it's important, but what are isotopes? Any nuclei that has the same atomic number but different mass number. Isobars, they have same mass number but different atomic number. And isotones have same number of neutrons. They're isotones. You can look at the examples as well. Now, the size of the nucleus is always given by R is equal to R naught A raised to 1 by 3. Okay. Yeah. Now, properties of nuclear forces. What are properties of nuclear force? They're all strongly attractive. Okay. Nuclear force, they're very attractive and they're very short range force. Okay. What do you mean by short range force? They attract at a very short range. If they're like this far apart, they don't attract. Very close together, they attract. They're charge independent. Positive will also attract. Negative positive will also attract. Negative will also attract. Independent of charge. They're spin dependent. They're exchange force and they're saturated forces. Okay. Okay. Next is difference between nuclear fission and nuclear fusion. Okay. Nuclear fission is when it's breaking. Fission means breaking. Fusion means joining. Okay. So if you have a nucleus of a heavy element and it splits into two light elements, that's nuclear fission. If you have two light elements and you fuse it to get a heavy element, that's called nuclear fusion. Okay. So breaking down can happen at any temperature, but joining together can happen only at very high temperature. Okay. Now, energy is excuse me. Okay. So energy is released per fission is high, energy released per fusion is low. Obviously, when something breaks, it releases a lot of energy. But when something fuses, it releases very small amount of energy. Now, when something breaks, there will be a lot of radioactive waste. When something joins, there's no waste. No radioactive waste. Okay. Next is Semiconductors. Okay, last topic. So I'm going to finish my class in less than 10 minutes. So what are the what are the three different types of elements? Yes. So first, conductors, semiconductors, insulators. What are conductors? The main difference is all three has a conduction band and a valence band. Okay. So whatever element it is, it has a conduction band and a valence band. So this valence band has electrons. So these electrons have to move to conduction band for that particular object to conduct. Now for conductors, the valence band and the conduction band are right one above the other. There is no gap between them. So electrons can smoothly move from valence band to conduction band. Okay. So this gap is zero. That is why they're good conductors. Electrons can easily move. But you can see in a semiconductor there is a gap. The gap is less than 3 eV, but there is a gap. So which means electrons can move, but if given a push. But for insulators, the gap is greater than 3 eV, which means electrons can never move. That is why insulators never conduct. Like plastic. Can plastic allow electrons to pass through? No. Because in plastic atoms, the valence band and the conduction band are at a huge gap. Okay? Yeah. So it has low resistivity, moderate resistivity, high resistivity. They allow, same thing I already discussed, they allow current to pass through. They allow, but not as good as conductors, but not as bad as insulators. Insulators don't allow. Okay. Now their conductivity decreases with increase in temperature. What happens in conductors? In conductors, when temperature increases, particles move very fast. Which means, the resistance becomes very high. So conductivity will reduce because the what happens? Because electricity won't be able to pass through it smoothly because particles are all crowded. See, just like you have a classroom full of students running around, will the teacher be able to walk through the class? No. Same thing. I'm not talking about you students, okay? Some naughty students are there. No, I'm talking about them. Conductivity increases with increase in temperature. So in a semiconductor, when temperature increases, the electrons have more energy to move to conduction band. So it is better. Conductivity is zero. Temperature high or low, it does not matter. Okay. In conductors conduct due to free electrons. Semiconductors conduct due to free electrons and holes. Okay. In conductors, the conduction band is completely filled with electrons at above 0 Kelvin. It's partially filled in semiconductors. Okay. Next is the difference between intrinsic and extrinsic semiconductors. So intrinsic semiconductors are pure semiconductors. Extrinsic are doped. What does dope mean? Some impurities are added to it. Okay. Now, conductivity is due to both electrons and holes. Extrinsic is conductivity is mainly due to majority charge carriers. So for intrinsic, it's just a pure form. So it will not have a lot of conductivity. It will have equal number of holes, equal number of electrons and all of that. But when you add impurity, you change the number of electrons and holes. So when you change the number of electrons and holes, what happens? Conductivity will change. Okay. Now, this extrinsic semiconductor can be divided into two, which is P-type and N-type. Okay. So, extrinsic semiconductor is divided into P-type and N-type. So, P-type uses trivalent dopants. What does that mean? There are 3 electrons in the dopant. So, if the initial semiconductor has 4, then 3 electrons are added. Total you need 8. So one extra hole is there because there is no electron there. So there is an extra hole there. That is why it will have holes as majority charge carriers. Okay. Minority will be electrons. Now for N-type, the initial pure semiconductor has 4 electrons. You add 5 more electrons. So what happens? There is an extra electron. So in that case, electrons are the majority charge carriers. Okay. Yeah. Next is forward biasing of a diode. So forward bias is when the P-type is connected to positive, N-type is connected to the negative. PP. P is connected to positive, N is connected to negative. That's when the diode functions normally. It functions perfectly. Okay. So here in this case, the width of the depletion region will decrease. Okay. And the potential at the junction will decrease. There is a charge carriers and current is mainly due to majority charge carrier. And this is the graph. So initially it doesn't conduct, but after the voltage is above threshold, it conducts properly. Now reverse biased is when the opposite. N-type is connected to positive. So in this case, it does not conduct well. Depletion region is very high. Okay, the depletion width of the depletion region will increase, junction potential increase, and conductivity is mainly due to minority charge carriers, and this is going to be the graph. Okay. Next is a half wave rectifier. Now, a device that converts AC to DC is called a rectifier. Okay. So you have AC current coming in. So AC current is current like this. So it has positive and negative half cycles. A diode is a device that allows current to pass through only in one direction. So if the positive part passes through the diode, you will get the output. But if the negative part passes through the diode, you will not get the output. Why? Because diode only conducts in one direction. So you can see the input is positive and negative. So whenever the positive comes, diode has an output. But the negative comes, diode has no output. So what is the output now? The output is a DC signal. Okay. So what did the half wave rectifier do? It converted the AC signal into a DC signal. So half wave rectifier will have out high, low, high, low, high, low. Like that, it would be like that because it has only one diode. So whenever diode is positive, you get an output. When diode is negative, you get no output. That's all. But in the case of a full wave rectifier, what happens? You are getting, see, output everywhere. But how? Diode only conducts in one direction. How? The answer to how is you have two diodes. Okay? And the two diodes are going to conduct in two different directions. So let's say this is positive, this is negative. So when the positive part reaches diode D1, it conducts. When the negative part reaches diode D1, it does not conduct. When the positive part reaches D2, it does not conduct. But when the negative part reaches D2, it will conduct. See? So you will get an output every time because the positive and the negative is in proper arrangement with respect to D1 and D2. Both of them will conduct. Okay. So the explanation is written here. I'll share these notes with you. So these are all some important concepts, some most expected concept for your second PUC. Okay. But if you just watch this, you will not get 70 on 70. Okay, because these are all most expected questions. In the next class, I will be doing 2 markers, 3 markers and 5 markers. So please send this class link to all your friends. Tell them to revise all these concepts and come for tomorrow's class where we will be discussing all the important questions. Okay, students, we're all putting in so much effort and the only thing we want you is study. Okay, so the next few days, take away, remove Instagram, everything from your phone. Keep only YouTube. Watch these lectures, look at the notes, study properly, you will all score very well. Trust me, you will all score very well. Okay? Yes? No tension. Only studies. Yeah? Pramila ma'am will be taking classes soon. Okay? Rutin, you can just look at the live section. Classes are scheduled. So you can look at that and timings will also be there. Okay? Okay, Runit? Sorry, Rutin. Rutin. Yeah? Okay, do you have any doubts? Otherwise, we can wind up today's lesson. So, I want to see you all in tomorrow's class. Okay? So, tomorrow's class link is already there. You can go to Vedantu Karnataka under lives. 2 markers, 3 markers, 5 markers. That thumbnail video is tomorrow's class. So, all of you please send that video to all your friends. Tell them to join at 11 in the morning. Okay? Yes? Agreed? Yeah. So I'll see you all tomorrow with another video. I hope you enjoyed the class. All the best for your exam 3. Okay? Yes. Yeah. Hi Harshita. Okay. I'll see you.